Welcome to qnawire.
Hello friends, here it is given a parallel link mechanism ABCD is used to transport a component I between manufacturing process at stations E, F and G. Picking it up, component I is picking up at angle 0 degree and depositing to the next station at 180 degree. It is given that BC always remains horizontal and link AB and CD rotate at constant rate in a vertical plane. If coefficient of friction between the component I and member BC are μs is 0.35, that is static friction, and kinetic friction is 0.25, then first part, calculate maximum speed of V. If component not slide on BC, and in second part we have to find the theta for which sliding is impending. Let us start solving. First we will draw the free body diagram of the component I. Weight of the component acts vertically downward. Normal reaction and friction. And having normal force m into an in this direction, and here normal acceleration is v square by rho. This is angle theta. It varies. Now taking summation of force along x direction, this is considered to be positive. So you may write F is equal to MAN cos of theta. B can write the mass in terms of weight. So weight divided by G. Normal acceleration is v square by rho into cos of theta. Say equation 1. Excuse me please. Summation of forces along y direction and minus weight to v minus weight by g by rho sine of theta. So from above equation, excuse me please, normal reaction having the value 1 minus square of speed at b upon rho into g sine of theta. Maximum friction may be mu s into n. So it would be mu s w 1 minus square of speed upon rho into g sine of theta. For component not to slide, F must be less than F max. So we can substitute the value here from equation 1 and 2. Weight divided by g square of speed upon rho cos of theta to be less than mu s w 1 minus v square by g into rho sine of theta. So from above equation, square of velocity will be less than mu s g into rho upon cos of theta plus mu s sine of theta. Say equation 3. For satisfying the condition of inequality, condition of inequality, v square v max must be less than or equal to minimum value of mu s g into rho divided by cos of theta plus mu s sin theta, which occur when cos of theta plus mu s sin theta having maximum value. Thus, d upon d of theta to be cos of theta plus mu s sin of theta must be 0. So from here you may get minus sin of theta plus mu s cos theta to be 0. So tan of theta to be mu s, and here mu s is given 0.35. So theta will be tan inverse of 0.35. So this angle you will get 19.29 degree. Answer of part A. The maximum value of velocity is v square max would be mu s g into rho upon cos of theta plus mu s sin of theta. Here mu s is equal to tan of theta. So we can write v square max to be g into rho tan of theta upon cos theta plus tan theta into sin theta. Now substituting the value, g is 32.2, rho is given 10 by 12 feet, and tan of 19.29 upon cos of 19.29 plus tan of 19.29 into sin of 19.29. On solving it, maximum speed you will get 2.98 feet per second. Now answer for second part B. Angle theta may vary from 90 degree to 180 degree. Equation third becomes square of velocity. Use the equation third should be less than mu s g into rho upon cos of alpha plus mu s sin of alpha. Here alpha is 180 degree minus theta. So theta we have measured 19.29. So alpha having the value 160.71 degree. Substitute the value. We have impending motion. To the left for theta to be 19.29 degree, and to the right for theta to be 160.7 degree. That's all for it. Thanks for watching it.